Good evening, friends. Today we will see the next problem in ladder friction. You can see here a ladder is on the wall and the floor. On the floor it is 60-degree incline and is on the exactly touching the floor at A, and on the wall it is touching at B. The ladder is tied with a string which is attached at E. So there will be a tension at that string. So what this string is trying to do, it is pulling the ladder to the right side. So the ladder tries to slide upwards. The ladder tries to slide upwards. So the ladder length is given 10-meter. Ladder center point where the weight of the ladder is acting, that is 900 Newton, is exactly 5 meters from A, and where the string is tied to the ladder is exactly 2.5 meters from A. And in this problem, it is given that mu wall is 0.4 and mu floor is 0.25. So the frictional force is 0.4 mu into NB, 0.4 NB. The frictional force in the floor is 0.25 into NA, that is mu A into NA, 0.25 into NA. That is a different frictional coefficient of friction is given in this problem for wall and the floor. Now, there will be a normal reaction acting at the floor at A, that is NA. There will be a normal reaction acting at the wall, that is NB. Since the ladder tries to slide upwards due to the tension in the string T, there will be upward movement in the wall, so there will be frictional movement downwards will be acting 0.4 NB. Here you can see at A it is moving to the right side. It is due to the tension in the string, the A point is moving to the right side, so there will be a frictional force on the left side, that is 0.25 NA. What is R? What is T? Tension T here. So this is the problem. So how to solve this problem? As I told in the previous problem, you have three equations to solve the rigid body in two dimensions to be in equilibrium. They are summation of f of x is equal to 0, summation of f of y equal to 0, and moment about a at or b any point is equal to 0. We will take the first equation, summation of f of x is equal to 0. So in this, what are all the horizontal components we have? This 0.25 NA, NB we have, and we have T. So T is positive. We will take T minus 0.25 NA minus NB is equal to 0. That is going to be our first equation. So you can see that I have written it here. T minus 0.25 NA minus NB equal to 0. This is the first equation I have written. The second equation is the summation of f of y equal to 0. What are all the y components we have? We have the y component as NA, 0.4 NB, 900. What else? That's all. So NA minus 0.49 NB minus 0.4 NB minus 900 is equal to 0. That is the second equation. You can see here, I have written it here. Na minus 0.4 Nb minus 900 is equal to 0. That is the second equation, summation of f of y equal to 0. Then coming to moment about A equal to 0. I am going to take moment about A. So this point. In this point, what are all the forces passing through that point? NA and 0.25 NA. There is no moment about that two forces. So you leave it these two forces. Then coming to T, you take T first of all. T is T in what is the perpendicular distance to this A? I am going to take moment about A. What is the perpendicular distance to this A? This distance. this distance will be this triangle. If you consider this triangle, the hypotenuse is 2.5. So, and this vertical distance will be the opposite side. So, 2.5 sine 60 will be the perpendicular distance. 2.5 sine 60 will be the perpendicular distance. So I am going to take t into 2.5 sine 60, and this t is acting at A, it is rotating clockwise, so it is minus t 2.5 sine 60 I have written. The second force is 900. 900 is acting downward, and again about A it is clockwise, so it is minus 900. So minus 900 into what is the perpendicular distance? It is a horizontal distance for a hypotenuse distance of 5. So horizontal distance is, what is the horizontal distance for hypotenuse 5? 5 cos 60. So 900 minus 900 into 5 cos 60 is the second moment I have taken. Then the third moment, 0.4 NB, you take 0.4 NB, 0.4 NB again to A, it is rotating clockwise. So it is also minus 0.4 NB, and what is the horizontal distance to 0.4 NB? It is acting at B. So what is the whole hypotenuse distance is 10. So 10 cos 60 will be the perpendicular distance. You can see minus 0.4 NB into 10 cos 60 is perpendicular distance. Then coming to NB about A, how it is rotating? It is rotating in the anti-clockwise manner. Anti-clockwise moment will be positive. So NB into what is the perpendicular distance? That is the vertical distance. So for 10 hypotenuse, the vertical distance will be sine component, that is 10 sine 60. So NB is plus NB into 10 sine 60 is equal to 0. I have 4 forces, 4 moments, that is equal to 0. That if I simplify it, it will be minus 2.165 T is first one, minus 2250 is the second constant, third one is NB, that is minus 2 NB, and fourth one is 0.866 NB equal to 0. Now you have got three equations. They are first one in yellow color, second one in white color, third one is in pink color. So three equations I have got. These three equations I can write it I can write it in terms of three unknowns. I have got three equations. How many unknowns I have here? T, Na, Nb. So three equations I have got, three unknowns you have. Very well, you can solve it by calculator. That three equations, how I can write it? The first equation is T minus 0.25 Na, Nb. The second equation is 0. The second equation will be 0 T. T is not there. So I can write it as 0 T plus Na minus 0.4 NB minus 0.4 NB. The minus 900 goes to the right side. It will be 900. So this is the second equation. The third equation will be this, minus 2.165 T plus 0 Na. There is no Na here. So I can take that is as 0. So the third equation will be, I am going to write the third equation. The third equation will be minus 2.165 T plus 0 Na plus, by adding this and this, I can have it as plus 6.666, sorry, plus 6.666. This is, sorry, this is not 0.866, this is 8.666. So I can take it as NB, 8.66 NB minus 2 NB will be plus 6.66 NB. This 2250 I am going to take to the right side, that is 2250. So now you have got three equations. One is yellow color, white color and pink color. That is, first one is summation of f of x, second one is summation of f of y. This is moment about a equal to 0. So three equations, you can solve it by calculator. Three unknowns I have, T, N, A, N, B. So I will get T as 928.71 Newton, Na as 1155.89 Newton, Nb as 639.73 Newton. You can check. Thank you.